So despite the fact that most people nowadays use flat panel televisions, the good old CRT television will always be remembered, and I think that there are two main reasons for that. Firstly, the CRT television was an incredibly important invention. It made video and television possible in the first place. Secondly, flat panel would just be an awful brand name. Okay, so we'll start off with the black and white or grayscale version of the CRT television, and we'll take a look at the colour version after that, because the colour version is based on the same principle, but it's a bit more complicated. Okay, so first of all, CRT stands for cathode ray tube, and that's because the cathode ray tube is the biggest, most important part of the entire CRT television. Now, a cathode ray tube is basically just a glass tube that is sealed entirely and there is no air inside it, so it's a vacuum, and you'll see why that's necessary in just a moment. So here's my very schematic drawing of such a vacuum tube, right? So at the front of the tube, that's the screen. That's the part of the television that the person watching is actually looking at. And this screen is coated in a layer of phosphor, and we'll talk about why that's necessary also in just a moment. At the back of the tube, we've got an electron gun and a couple of electromagnets. Now, an electron gun, let's zoom in on that component a little bit more now. This is my schematic drawing of an electron gun. So as you can see, it consists out of a coil-shaped thing that we call a cathode and a plate that we call the anode. Now, what happens inside an electron gun is the following. First of all, an electric current goes through the cathode. This heats it up like the filament of a light bulb. Because of the heat, electrons, so negative particles, start to escape from it. At the same time, the anode, so that's the plate on the other side, is highly positively charged, which means it will attract the electrons that are escaping from the cathode. And this creates a beam of electrons that goes from the cathode towards the anode. Now, as you can see, there is a hole in the anode, so the electrons will fly through that hole out of the gun, and that's how the electron gun fires a beam of electrons. Now, all of this has to happen in a vacuum. If there is air, then these electrons won't fly. That air is an obstacle for them. So that's why the cathode ray tube has no air inside it. Okay, great. So we now know what the electron gun does. It fires electrons. Now let's take a look at what happens when you actually switch on your television. And so in order to look at that, I've made this. So this is a more three-dimensional version of the schematic drawing that we were just looking at. So we've still got the electron gun at the back. Then we've got those electromagnets, so they're coils, as you can see. And then the screen is in front of all that. So these electromagnets have the task of aiming the beam. So one of them is positioned horizontally and one is positioned vertically, which means they can use their magnetic fields to either horizontally or vertically move that beam. So these magnets are there to aim the beam at specific locations on the screen. In this case, the magnets will aim the electron beam at the corner of the screen like this. Okay, so we've now got a beam that reaches the corner of the screen. Now, this is where that layer of phosphor comes in that we talked about. Phosphor is a substance that lights up when it's hit by electrons. So, when this electron beam hits that corner of the screen, the phosphor in that location will start glowing, and it will produce visible light. And so, the person watching TV will then see a dot in the corner of the screen, like so. Then the electromagnets will start moving the beam of electrons across the screen to the other side, like this. And then they will move it down one step and repeat that. And that way the beam will scan across the entire screen. So the person watching TV will now see a dot moving over the screen like so. Well, actually, that's a lie. Okay, that's not what happens. Because this dot moves way too fast for the human eye to see. This dot scans over the entire screen 50 to 60 times per second. That's how fast the electron beam scans over the entire screen. And therefore it will look as though the screen is just completely white. Great, so we've now learned how a television creates a white screen. So now the question is, how does it produce an image on the screen? Well, first of all, in order to create an image, we need an input signal, right? We need some signal from, let's say, a video recorder, right? It's a CRT television, so it's also a video recorder. So we get our signal from the video recorder. Now that signal has a certain voltage. Here comes the trick. The voltage of the input signal controls the power of the electron gun. So it also controls the power or the intensity of the electron beam. And therefore it controls the brightness of the dot on the screen. So think of that for a second. The brightness of the dot on the screen is controlled in real time by the voltage on the video signal. And so by rapidly altering the voltage in whatever pattern you want, depending on what kind of image you want to create, you can make different parts of a screen have a different brightness, and that way you create a grayscale image. So that's how the grayscale television works. Now the color CRT uses exactly the same principle, but with a couple of modifications. First of all, it uses 3 kinds of phosphor. So instead of using one big layer of phosphor that lights up white when it's hit by the electrons, it uses dots of phosphor spread over the entire screen of 3 different kinds. One of them glows red, one of them glows blue, and the other one glows green, so RGB colours. And also, we have 3 electron guns, which all aim at a slightly different position on the screen, but very close to each other. Now, what we can do is scan across the screen with these 3 guns simultaneously, and we can control the intensity of each gun separately to control the intensity of each color channel. And that way we can create color images on the screen. So it's the same principle, but it just adds more components and complexity. So that's why it took longer to develop color television. Well anyway, there you go. Now you know exactly how a CRT television works. I hope you've enjoyed this video, and thank you for watching.